Hello and welcome to the channel. Kolmogorov School is run by the Moscow State University for talented students who completed year 9 of the standard school curriculum. The education takes 2 years and majority of the students completed it continue education at the university. Here is one of the problems from the admission exam in year 2006, which I found quite challenging given that the book had the answer but no solution. This is what the problem is about. A person usually arrived by same train service at same time, precisely at the time of arrival, no later and no earlier. A car came to the train station to take him home. One day the person arrived an hour earlier, and no car. What an upset. So he walked, met the car on the way, and arrived home by car only 20 minutes earlier than usually. The question is, how long did he walk? To make it clear, let's draw a plan. So we have point A, home of our precious person. Point C, the train station. The way home from point C to point A. We also have point B, the garage, from where the car departs. But the tricky question is where to place it. Nothing stops us from placing the garage opposite to home. So the car gets to the station, picks the passenger and continues to his home. All that looks logical. However, we know that the person met the car on his way. And in order to meet the car, he had to walk towards the car, opposite to home. Well, there is nothing wrong with that apart of a minor nuisance. By doing that, he would arrive home at the usual time, whereas the conditions clearly mention that he arrived 20 minutes earlier. This may happen only if the garage is located at the same site as home. In addition, the roads from train station to home and the garage must have a common part, containing a very important for the solution point Z, where the walking person met his highly anticipated car. There is another assumption not mentioned in the conditions, but making sense to me. From the meeting place to the station, the car uses same road and moves at same speed as on the way back from the station to the meeting place. If you can get a hint out of my rather boring introduction, you will be able to solve the problem in mind using only 2 arithmetic operations. So please pause the video and try to find the solution. Poor car driver leaves the garage at usual time, being unaware of the surprise prepared for him. In such an awareness, he drives at full speed, expecting to be at the station just in time with the expected arrival of the train. However, while passing through point Z, he suddenly hears the voice of his boss shouting, "Halt, I am here!" He brakes, picks his boss and makes a U-turn to drive back. All that happens in a jiffy, at negligible time. More precisely, we assume the time to be negligible and ignore it. There are so many things in our life that we are forced to ignore. As a result of this maneuver, he brings the passenger home 20 minutes earlier than usually. The time was saved only because the car didn't travel from point Z to C and back from C to Z. This leads to the following conclusion. The way of the car from point Z to point C and back takes 20 minutes. Therefore, according to the assumption, the way of the car from Z to C one way takes half of that, or 10 minutes. Taking a half is one of the 2 mentioned arithmetic operations. Can you think of the second operation? Now we know that the driver expected to be at train station 10 minutes after passing point Z. In other words, The car appears at point Z 10 minutes before the expected train arrival. At the same time, the walking passenger reaches point Z. So the passenger appears at point Z 10 minutes before the expected train arrival. This makes everything completely clear. We know that the person appears at the train station, point C, 1 hour or 60 minutes before the expected train arrival, and meets the car at point Z 10 minutes before the same event. Therefore, walking from the train station to meeting the car took the difference, 60 minus 10, which is 50 minutes. This is the time we needed to find, and we found it. So the answer is 50 minutes, and this is the end.